Okay, so here we are with some practice on how to use the no formula product rule for calculus differentiation. We're going to get our two functions here, can't combine them, not going to happen. We begin with our box. Important to say, you probably want to see the previous video on this explaining it. It's going to look like this. It would be much better to have that basis before starting these. This one's going to be a product rule. So we're just going to label what we're doing. U is x cubed. V, we're defining it as the other function there on the right. U dashed is 3x squared and V dashed is e to the x. We love that. What's the method here that's with the product rule? It's going to be the cross effect. So we'll just write dy by dx. Top left to bottom right, x cubed e to the x, and we're going to sum the 3x squared multiplied by e to the x. And there you have it. Of course, you can go on and factorize out. Okay, so x squared e to the x is coming out, and we're left with an x plus 3, and that's the derivative. Okay, so next one. Okay, so box as usual. We got u equals x squared, v is ln x, u dashed is, yep, you got it, v dashed is, yep, you got it. I'm going to be careful here because 1 over x sometimes means cancelling, so we'll be careful. Dy by dx is equal to, I'm going to multiply them two together, and that's 2x ln x. All right, some cancelling is going to take place, and we can factorize out an x. It's generally seen as neater if you have factorized, and having factorized is typically how we solve a lot of functions. Okay, on to the next one, and well done to anyone who's ahead of me, trying to beat me. Okay, where are we at? We've got u dashed is 4x cubed, v dashed, the sign goes to a positive cosine, but this is going to a negative sign. Let's put this together. We've got the product. So you always got to keep the habit of what you do each time, because those habits are what carry you through into the exam. When you're really nervous, those habits are it. Okay, dy by dx, 4x cubed cosine x plus, is it going to be negative? Look, x 4 sine x. Okay, I was a bit panicked there because I was running out of space. We can take an x cubed out. That's it. 4 cosine x minus, about as much as we're going on that one. Okay, looking at this last of the basics, u equals e to the 2x, yes it does, and v equals, what is he doing? Yeah, I'm writing it in a form which is in the exponent form, so we have a better chance of doing this properly. And this is another case of a chain rule, if you can see. So u dashed is going to occur with a chain rule as well. Should we do mini chain rules? Probably do these ones in your head. We're going to need a couple if we do, okay? So this first chain rule is e to the 2x. So this is where u equals 2x, u dashed is 2, and then we have the overall function, we can just call it y equals e to the u, and then y dashed equals e to the u stays the same. So from that we can conclude, because this is a chain rule, that we multiply the bottom two terms to get the result we want. That's going to be 2 multiplied by e to the u, and we know that u, in the previous case over here, was equal to 2x. We get our definition of u from here, not from our question over on the left. Okay, we've got a second chain rule to enact because of the v. The u in this case is 2x minus 3, if you can tell. We're going to have something inside a square root function, basically. For the purposes, we'll just say y equals u to the half. U dashed is 2, y dashed is going to be. So to combine this again, we're going to multiply across because it's a chain rule. Okay, that's really good. U was 2x minus 3. If you want to, so that's 1 over the square root. What have we just found? We found the result of our chain rule. In this sense, it's our bottom right element, so v dashed. It might be best at this stage to be writing it like this though, because we're about to multiply things. Okay, all we have to do now is remember that overall we were trying to do a product rule. So it's this times this plus this times this. That's going to be add the multiplication of the other. So that's 2e to the 2x minus 3 all to the half. There is a way of combining those, but we're going to leave it there. We're going to go on to a challenge one. What do you think first you would do. And it's not draw the cross, actually. Looking at it, we've first of all got to think about what structure. The way I see it, I have e to the x. And the other function I have is they're two separate functions. There'll be x squared times x plus 3. So potentially that's u and that's v. If I ever needed to differentiate this entire function here, I'd probably have to use the product rule. Bear that in mind. And so the overall thing going on here is actually, first of all, chain rule. We're going to say that u equals x squared root x plus 3, y equals e to the u. Okay, so far so good. We're going to have to differentiate this. Differentiate that, we're going to have to set up a different thing. Okay, we're going to call it the product rule in order to differentiate what's going on there. And the product rule says that we have one function, but it's being multiplied by another function, v. Again, we're not going to square root that. We're going to write that as x plus 3 to the half. As typical, we've got u dashed to x, and we're going to find v dashed again with a chain rule. So chain rule is going to be over here for this. It's going to have u equals x plus 3, y equals u to the half. U dashed equals 1. Thankfully, that's nice and easy. And that's a half u to the minus a half, which we know with the chain rule, we're going to multiply these two together. The 1 is now no effect. So we've got half of x plus 3 to the power of negative 1/2. If we need is 1/2 multiplied by 1 over the square root of x plus 3. We'll leave that aside for now. We'll see how I decide to play it. We were going from here, so the result goes here. We've used our method fully just once in the pink. Now coming back to complete our method with the product rule, because we've got all of our elements. So the product rule says that we're going to make a product of these things. And remember, the overall was chain rule. Our aim here with the product rule is just to get to the bottom part here. There's many steps involved. What we're going to do is multiply across. We'll go x squared all over 2 root x plus 3 plus 2x of square root of x plus 3. Once we've multiplied and add together, this is the result that goes in the bottom left here. I think we can do something to tidy this up. We want a common denominator over on the right. We will multiply the top and the bottom by 2x plus root 3. And common denominators aside, we expand this in all over. That's going up the top there. Next step is to differentiate this side, which is thankfully the easy bit. What was our overall method here? What were we doing to begin with? It was just chain rule. In order to do the chain rule, we had to differentiate something that needed the product rule. And to differentiate the something that needed the product rule, we needed the chain rule again. So lots of stuff going on. Our last for the chain rule is just to multiply these two together at the bottom. If we just take it fact that y dashed is equal to e the x squared root x plus 3, it means that it's got to multiply the top there. And to be honest, I quite fancy having that separate. So don't be intimidated by this. It's just going to give you, it's just an expression, a complicated expression about the relationship of the gradient. But hopefully all of this has provided a good amount of practice for using our organized method of visualizing the formulae instead of remembering them. Okay, so this will conclude the product rule. And now it's time to head on to the quotient rule, where we will look at this same method and how it applies to there. Don't forget, for every Patreon sub, there's a free worksheet full of more practice on this.